Okay, please put the heading as limits.
Yes, done. Already noted.
Okay. So in your course, you will be learning about the limits in calculus. Okay. So what is the
Okay.
definition of limits? A limit is defined as a value that a function approaches the output for the given input value. Please note it down.
A value?
I'll just write it on the screen. Please note it down. A limit
Okay.
defined as is defined as a value
A value
that a
that
function
a function
approaches
All right.
approaches the output. It approaches
The
the output for
approach
the
the
given
output
input values.
for. Okay.
See, for example, assume you have a function as x square. What do
Okay.
you mean by input and output? We used to draw a table for drawing a graph. The graph
Okay.
must be an output, which is represented in the form of a graphical representation. So for example, I'll put x here. This is considered as input. The y is going to be, what is y? Y is nothing but f of x. That is going to be a output. So I can give several inputs, like I can give -1. I'll substitute the value in the function. I'll see what happens to the function. So when I substitute -1, it becomes +1 because it is square function. So if I substitute +2, it's going to be 4. If I substitute -2, it would be 4. If I substitute 0, it will remain 0. If I substitute positive, it would be +1. So this is how I'll get the input and out. I'll give few values in the input and I'll get the corresponding output. So this is what we'll do in the function. Do you understand the working of function?
Yes, I understand.
Okay. So this we are already doing. So what this limit has to do with it? So you will be applying certain limit to it. For example, you can have like f of x is equal to x square. And they will substitute some limit. For example, they will substitute x approaches 2. So what do you
Okay.
mean by that? So let's see that graphically. Because we already know what is f of x. We know what is f of x is equal to x square. How does it work? For example, I'll just mark all the coordinates 0, 0, 1, 1, -1, +1, -2, +4, and +2, +4. So it
Okay.
would be, actually I'm representing the coordinate in the form of x, y. So it's going to be
Once again,
0.
ma'am, x is -1, so y f of x is y.
Yeah. So when I substitute
Okay.
x as -1, I do have to square, right? Then only I'll get the f of
Okay.
x.
Okay.
-1 into -1 will give me +1. So the y should be +1, isn't it? Please tell me if you have any doubts. We'll discuss that again.
No, ma'am, no doubt. No
So
doubt.
the
No doubt.
left-hand side x-axis and the downward y-axis goes like negative.
Okay.
And this you are aware. The positive x-axis and positive y-axis goes like this. So the
Okay.
coordinates 0, 0 is here. 1, 1 is here. -1, +1 means it's here, right? And -2, +4 must be here. +2 and +4 must be here. So if I join all these coordinates, I'll be able to get my answer as the curve. So this is going to be my f of x is equal to x square. So this you are
Okay.
already aware. This you used to do it from the grade 9 itself. You know this.
Yeah, that is okay.
Yeah.
Yeah.
So what this limit x approaches to has to do. Okay, I have to brief about this representation to LIM denotes the word limit. Okay, limit. You are limiting the function to some value. Okay. So
Okay.
underneath they have mentioned x approaches to. So you have to read this as approaches or tends to. Approaches or tends to. Is it clear? This is not
Clear.
x is equal to 2. Okay, please be clear with that. X approaches 2 means it is not x is equal to 2. It is approaching 2. What do you mean by
Okay.
that? You are just, they say x is equal to 2, which means in x-axis, just focus on the x. In
One
x-axis,
second. One second. One
on the
second. One
value.
second.
This is 2.
Okay. Okay.
Yeah, yeah. Yeah, please carry on.
Oh, can you repeat? Can you repeat? Sorry, I didn't.
So I was saying
What did
that
you say?
x approaches
Okay.
2 means you have to focus on the x-axis. The x-axis you have 2 here. Did you see that? I have circled it.
Yeah. Yeah. Yeah.
Yeah.
I
So now
saw.
what
Yeah.
I'm going to do, I'm going to approach the value 2 from my right hand side and from the left hand side. Let me
Okay.
magnify this number line. Let me magnify it. So what happens when I magnify? So assume you have 2 here and 1 here and 3 here. Okay.
Okay.
Magnify. So you know this usually this happens like 2.5 is here, 1.5 must be here,
Yeah.
and next to 2 must be 1.9. But if you go,
Okay.
if you magnify this also, you'll be able to notice like 1.99999. Do you agree that? And
I
similarly,
agree.
if you
Okay.
magnify this, you'll be able to get like 2.11111 or like
Okay. Yeah.
2.00000.
0.00011.
Yes.
Okay.
So
Yeah.
so this can go on forever. Like you can magnify the number line, you'll be able to get n number of decimal lines. I mean decimal places, isn't it?
Yeah. That's true.
Yes. So
Yes.
in the limits, you'll be able to improve the accuracy. By using the limits, you'll be able to improve the accuracy of the function. So what do? You just have to go from the right hand side and from the left hand side towards this value, and you will see what happens to that function at that particular value. For example, in the same function you will substitute like 2.999 and see how it behaves, and you will substitute like
One
from the
point.
left hand side like 1.99, like 1.9, 1.99, 1.999, like 2.00, 2.0, 2.01, like that. Do you understand?
I got it.
You
Yeah. I
will
understand.
just go
But I don't understand what's the point of all this. Like,
yes,
what?
yes.
What do they? Okay.
You are just going very close to 2, but it is not 2. That is what you are doing.
Okay.
You're just going very close to 2. You will
Yeah.
substitute all the values very close to 2, but it is not 2.
Okay.
That is the point of
Okay. Okay.
you will go more closer and closer and you will observe the function.
Okay.
For
Okay.
example, if you look at the nature of the function,
Okay.
0, when you substitute 0, you got the output as 0. When you substitute
Okay.
1, you got the output as 1. When you
Plus one.
substituted the negative value,
-1.
the negative
Then
value turned into positive value.
positive value. Correct.
So these kind of property you are able to visualize for the integers, right? So what if it is decimal? So will it hold the same property if you substitute like 3 decimal places, 4 decimal places, 5 decimal places, 10 decimal places? You need to analyze it. Do you understand? So in your
Understood.
low, you won't do this much advanced level. You will be substituting few decimal places, but you won't do this for every problem. Of course you will learn
Oh,
about this maybe 1 to 2 problem. You won't do it for all the problem. Now since I'm teaching you the basics, I'm telling you why we are using the limits, because we already have f of x. So why this limit has to do with the mathematics? So I'm just explaining the purpose of using the limits here. Do you understand?
okay. Understood.
So by substituting all this value, you will come to a conclusion. You would be able to generalize the property about this function. Then you will conclude this is how this function behave. Even if you substitute 10 decimal places also, the nature of the this particular function will give answer in a certain way. Do you understand? So you will do more analysis here, like
Okay.
like how we do in the laboratory, like that you are doing mathematical laboratory here. Do you understand?
Okay. Understood.
All right. So I was
Like
saying that,
like trial and error, right?
sorry,
Like trial and error.
like this is like you are not doing trial and error. You are substituting so many values and you're just observing. You're just doing the observation. For example, when you do the program, you will substitute some random values and see how the program will give you the answers. And they'll ask you to give several values in the program and they'll ask you to check the output. So that program will hold the same condition for the decimal values also. You can give integer values also. You can give fraction values also. We'll just see whether we'll get the output or not. Okay, so you're
Okay.
doing the same. You're just doing the same here.
Okay. Okay, ma'am.
Excuse me. So, so why we are doing this again and again? Why we are doing it?
Which one?
Just
This
to just to give
okay.
the proper definition. That's it.
Okay.
Just to
Okay.
give the definition about the function properly. Okay.
Okay.
All right. So let me tell you, like I was telling you that you are approaching 2 from the left side and right side. So I'll tell
Okay.
you how we do in general. How do we do that? I'll show you.
Okay, ma'am.
Assume you have a like 2 coordinate axis like this. I mean, I'll
Okay.
just put it as x-axis and y-axis. Assume you have a x-axis and y-axis. We'll go for the same graph, the x square itself. You do have a graph like this. I'll just
Okay.
mark. I'll just take only the right side part of it. Okay. So assume you
Okay.
have a graph like this. I'll just teach
Okay.
you with the real-time incident itself. For example, let's assume this graph is related to some CCTV footage on the traffic. Okay, let's
Okay.
assume someone violates the traffic law. Maybe he exceeded the speed limit. So now this traffic police needs to chase this guy through the CCTV footage. So this is the scenario. So let me depict that in the graph. So let's assume this is the speed. This is the speed. And let's assume this as the time graph.
Okay.
I mean, this is the time axis, this is the speed axis. So maybe this I'll put it. So let's assume this is like at 8 a.m. and here like at 8:02 a.m. and this one is like 8:04 a.m. I mean like 8 to 8:04. I hope you're able to follow what I'm trying to say.
I
Like this is
am.
like 8:06 like that. Like
8
8.
10.
Okay.
8.
Could you? I don't know the exact speed limit. Could you suggest me some number like a kilometer per hour? Can you suggest me some speed values?
So it
Suggest
actually
me some
starts with
normal speed values.
starts with 15 kilometer per hour.
15.
Yeah.
Oh, okay. Okay, let's assume like 50. Let's start from 50.
Okay. 50
50.
kilometer.
And what is the very bad speed?
80. Yeah.
Oh, 80 is itself a bad speed. Okay. So,
No. You're talking. Okay, fine. Yeah.
I'm asking about in Chennai only. Let's these people used to go through this KTM bike and all that. What is a bad
Yeah,
speed?
that's 80. 80 is bad.
80.
Yeah.
Okay. So
Yeah.
let's assume 80 kilometer per hour. Let's assume also like 90 also he tried. Maybe he created
Okay.
some accident or something. Let's assume a situation like that, like 90. And again, he has changed the speed, like maybe like again he went to 60 kilometers because the speed is fluctuating. Like in real time, like the graph won't be always increasing. He might decrease the speed as well.
Yeah, I might decrease the speed. Yeah.
60 kilometers, 70, 60, like that. It goes. All right. Maybe you will get the graph like this also. It might go like
Yeah,
this.
yeah.
But we are not
Correct,
worrying about this part. We are focusing only here.
Yeah, okay.
Okay. Okay. So let's assume the traffic police is tracking this event, but he are not sure about the exact time. He are not sure about the exact accident duration. So, but he has some approximate detail. He knew that it happened around from 8 to 8:10. You're not sure about the exact second. Okay. So let's assume he was busy with some work. So he know two different values, but here he is not sure the exact value, like this value and this value. Maybe he knew about, he know it happened between 8:3 and maybe like 8:6. He don't know the exact second because he need to report all that, isn't it? So he know two values. So in mathematics, let's go back to mathematics and see. When you approach a curve through two different line, I mean two different point. When you approach a curve through two different point, and assume you're analyzing it, and if you're drawing a line through these 2 points, you will consider these line as a secant line.
Secant.
You will consider these two lines as secant line. Let's name this as like maybe like P1 and P2. Okay,
P2.
let's name these 2 points as
P1 and P2.
and P2. This is secant line. So assume he is going to the court in the trial of court. He is stating that this must have happened between 8:3 and 8:6. Definitely he'll get scolded, right? He has to give the exact detail. He has to give one particular value. Why we need the one particular value? For the trust, for the accuracy about the information, isn't it? You need the accuracy about the information. Same goes with the mathematics too. So if I do analysis with the two different point, the accuracy is somewhat missing. Some little amount is missing. So what do I have to do? I have to go very closer and closer to a single point. So now I have to go little bit closer. So let's assume I have moved from here to here. So let's assume these 2 points is Q1 and Q2. Okay, Q1 and Q2. So now he's very sure it must have happened between 8:4 and 8:5 only. Okay, must be between 8:4 and 8:5. So now if he goes little bit closer, he will be ended up having a single point. Maybe let's mark this point as R at single point. So maybe let's assume it happened at 8:4 minutes 30 seconds. So it exactly happened at that particular point. So R is equal to this value. Let's assume that. So do you think the accuracy is improved now?
Yeah.
Yes. When you compare to P1 and P2 situation, Q1 and Q2 situation, you can see the accuracy is improved, isn't it?
Correct. Yes.
Yes. So what I'm doing here, I'm limiting the function to a single value. Do you see that? I'm limiting the whole accident situation to a particular value. Now the accuracy is improved. I can describe the situation with much clarity, right? So same thing happened with the mathematics aspect. So I told you this, when I approach a curve through 2 points, I'll call that connecting line a secant line. So when I move closer and closer, and if I approach the function through a single point, and if I draw a line over it, I'll call this line as a tangent. You must have heard about this line. This is tangent. This is tangent. So I can go for this. This is much better. Tangent line looks much better than the secant line because I do have accuracy here. So this is limit. This is limit. So when I say f of x is equal to x square, I'm just defining a function. You can substitute infinite number of value. You can substitute like 10 different negative value. You can substitute 0, 10 different positive value. Okay. Maybe sometimes what happens, the function behave like this for like 20 to 30 value. Maybe after some particular value, the slope might go down also. Maybe for this function, it is very easy. What if I give like x square plus 3, or what if I give like x square minus 3? Some changes will happen, right? So to observe the nature of the function, I should not blindly state the function as f of x is equal to x square. If I limit the function to a particular value, like how I limited the accident duration as 8.4 minutes 30 seconds. So when I say I have to approach this function from 2, I will only focus on the values very closer to 2. So now I can
Okay.
have a much clarity about this function. The accuracy about this function also will be improved. Do you understand?
I understand.
Yes. So this is the purpose
Yes.
of limit.
Okay.
All right. So I hope you have understood. So when you approach the function, you will be approaching the function from the left hand side and the right hand side, because in the number line you do have two different directions, isn't it? So which is why you are approaching from the left side and the right side. Is it clear?
Yes, clear.
Yes. All right. Okay. So this is the purpose of using the limits. Let's go to few basic properties of limits and we can solve a problem. Very basic
Sure.
property. You just have to note it down. Very easy only. Don't worry. So the properties. Properties means like how it behaves for addition, for multiplication, for subtraction, like that. Very easy.
Okay. Okay.
For example, let's assume
Okay.
you have a limiting function for f of x. This a is nothing but some value. For example, I gave you x approaches 2, right? Like that I can give 3, 4, -1, -2. I can give 100, 1000 like that. That is a.
Okay.
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 And let's assume, what if I'm multiplying the function with a constant? I'll just use different color. I'm multiplying a function with a constant. I can take the constant outside. I can push the limit inside the function. For example, we were discussing about f of x is equal to x square. And also, I gave you limit like x approaches 2. What if I gave f of x as 2 times of x square? The 2 is the constant, isn't it? So I don't
Yeah.
have to change the entire problem. Now I can rewrite my problem into 2 times of limit x approaches to f of x. And what if I gave my function as f of x is equal to 3x square and limit x approaches 2? What I'll do, this is the constant. I'll just take the constant outside and I'll just substitute the limit alone for the x square function. I'll just, when the constant is in multiplication, I'll just take it outside. I'll just multiply the constant at last. I don't have to worry about that. Maybe I can have, please note down all the examples. Maybe I can have like functions like 1 by 2 into x squared. This is also a constant. 1 by 2 is also a constant. I can take it outside and I can substitute the limit. I'm just using 2 here. You can use any value. You can put any
So
value.
these are all properties, right? This is one
I'm just
property.
explaining only one property with various
Yeah.
examples.
Understood. Like this, how many properties are there?
Like this, you do have like 6.
Okay. Oh yeah, 6. I heard
Deeper,
this.
you will be able to explore so many property. For the foundation, you will only explore 6 property. It's very easy only. It is not a big deal. Very easy.
1 second. Okay. Okay.
So what we are learning in this property, whenever the constant is in multiplication, you don't have to worry about the constant. Just push it outside. You just use the constant in the last step. That's it. And what if I have some constant? For example, let's assume you have a function as constant itself. Let's assume f of x is equal to 3. What do you mean by that? Y is equal to 3, isn't it? So how I'll draw
Okay.
this?
This is the second property.
This is not the second property. I'm just doing a problem. What
Okay,
if
okay,
you
okay.
have a function as constant? The function itself a constant. There is no variable in it. The function itself a constant. How do I plot this in the graph? F of x is equal to 3 means this is x-axis, this is y-axis. F of x is equal to 3 means how I'll draw? Y is equal to 3. Isn't it? 1, 2,
Yeah,
3. I'll draw a line like this. Right?
yeah, that's right. Okay.
That's it. So they're saying I have to limit this. Let's assume limit
Okay.
x approaches 2 of f of x. Do
Where
you
is this
think I
even
have
used?
to do anything with the 2 here? I'm having limit x approaches 2 for 3. Do you think you'd be able to make any substitution on the 3? Do you think you
No,
can make substitution over the constant? You cannot.
no.
You cannot. You can only make the substitution on the variable, which will vary. Constant is constant. 3 means it's only 3 only. You cannot change 3, right? So I won't be able to do anything with that. You can give 1,000 number of limits, but that is not going to affect my function. You can approach it from x is equal to 2. You can approach it from x is equal to 1. You can approach it from x is equal to 100. 3 is 3 only forever. I won't be able to make any changes. So this is the property. Limit x approaches a. You can substitute any value. The constant is going to be constant only. It will not change.
Okay. Okay, ma'am.
Do you understand this?
Understand.
I cannot make any substitution in constant. Okay, if you have that idea, then this property is very easy. You will
Okay,
not
so
be
what
able
will
to
be
make
the,
any substitution in the constant.
so that's it. The answer is 3.
That's it. That's it. The answer is 3. So you're just because like you might have an ambiguity. Like what if I substitute some values for the constant by using the limits, like how it behaves? Because I told you I'll go more and more closer to particular value and see what happens to the function. But here f of x is equal to constant. By seeing the name itself, we can understand. Constant means it will never change. If you do something in
Okay.
the limits, derivative, integration, calculation, you go to anything, it will not change.
Okay.
Okay, so that's it. And the third property, maybe let's assume you're performing addition between two functions. You do have f of x is equal to x square and g of x as x. How do you draw this function? So you may
If
be
okay, 1 second, ma'am.
assume f of
Yeah,
x plus g
okay.
of x. What is it? It's x square plus x, right? So maybe you will have a graph like this for x square. And what do you mean by x? You will have a line like this. This is y is equal to x. This is y is equal to x square, isn't it? Or else you might be having,
1 second, ma'am. So what will be
it
the,
might look like this. The graph might look like this. You will have a straight line. And you might be having a curve like this. Because it is a combination of curve and straight line, isn't it?
that's the second one you drew is the graph, right? For this?
You have to substitute some values and see how it behaves.
Okay, okay, okay.
Even I'm not sure first one or second one is correct. I'm not sure. But
Okay, okay.
it might look like first one or second one. Like you might have a
Okay,
curve and line, or else you'll have a line and curve. Only these two
okay,
combinations.
okay.
It's just an addition.
Correct, okay.
So when I substitute some limits to this function, so when I add the function, when I perform addition between two different functions and I'm limiting the whole function to a particular value, which means like you are observing this function from a particular value from the left hand side and right hand side, like you are magnifying it, you are improving the accuracy, these steps you are performing. So what do? You can go for distribution. You can distribute them for both the function. This is the property of it. And this is
Wait,
applicable.
wait. This is really confusing.
What
Wait
I'm
a minute.
saying,
Okay.
for example, assume you have like x square plus x for limit x approaches a. I'm saying it is equivalent to limit x approaches a x square plus limit x approaches a x. Do you understand?
Okay. 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 Yeah.
So we did that function. For example, limit x approaches 2 for x square, we did that.
Yeah.
I'm adding this means I can do the same thing separately for two different functions. And at last I can perform addition with the both the function.
Okay.
Do you understand? I
Okay.
can do it
Yeah.
separately. Like rather than doing like this, I can say this plus this. This result will be equal to this result. Do you understand? A plus
Okay.
B is equal to A
A
plus B.
plus B. Okay.
Is it clear?
Yeah, clear. I'm able to understand it very partially, not the whole.
Yeah. Like
This
when
thing.
you do the problem, you'll be able to understand. It will be
Okay.
very easy for you. Don't worry. Now we are just
Okay, ma'am.
discussing the theoretical part of it
The assignment questions are based on this only, right?
based on this only.